Today we will be doing 7.3 exponential growth and decay with shifts. At the end of this lesson, you will be able to graph exponential functions and describe key features, including shifts to the parent functions. So we're going to take our parent function, f of x equals b to the x, and we're going to be shifting it left, right, up, and down. The way you're going to know how to shift it left, right, up, and down is based off the equation y equals b to the x minus h plus k. When determining your left and right movement, or your horizontal shift, you look at what is attached to x in the exponent. A plus h means left h units, a minus h means right h units. You will always do the opposite of what it shows in the exponent. The number attached to x is your left and right movement, but you do the opposite. Then you'll look at your vertical shift. The k, or the number that's added on at the very end, or subtracted at the very end. A plus k means up k units, a minus k means down k units. Your vertical shift is always going to be exactly as you see it. Plus is up, minus is down. Your domain will always be negative infinity to positive infinity. You can plug in any x value you want to the function, but your range is going to be dependent upon what k is, how it shifts up and down, your vertical shift. Your range is now going to be from k to infinity, to where k represents an asymptote. An asymptote is an imaginary line that the graph will never cross and never touch. So example 1, given the following functions, describe the shifts. The parent function is y equals 2 to the x. The transformed function or new function is y equals 2 to the x minus 2 plus 3. I first look for my left and right movement. Attached to x is a negative 2. So with the left and right, we always do the opposite of what it shows. So a negative 2 would tell me I move the graph right 2 units. Then I look for my up and down movement. So I look for k. K is a plus 3. I always do exactly what k tells me. So this means up 3 units. Second equation, y equals 1/3 to the x power. The transformed function, y equals 1/3 to the x plus 7 minus 1. I'm going to look for my left and right movement. X plus 7. Do the opposite of that. So I move it to the left 7 units. And I look for my k. K is a minus 1, doing exactly the same movement that it shows, so down 1 unit. Third function, y equals 5 to the x. With the transformed function, y equals 5 to the x minus 1 minus 4. Left and right movement, x minus 1, do the opposite of that, so right 1 unit. My up and down movement, a negative 4, do exactly as it shows, so down 4 units. All I've done is looked at how the graph was transformed. What is now going to happen to x? What is now going to happen to y, which means the k value and the h value. So example 2, determine if the function is an exponential growth or decay. We're going to graph the function, and we're going to list the domain and range. I know this is exponential because x plus 1 is in the exponent. I also know that it's going to shift to the left 1 unit of the parent function. And the parent function is y equals 2 to the x power. So I could get my calculator, plug this into the calculator, and then use my table to fill in the values. But for this example, I'm going to do it by hand and just plug everything in. So if I take my first x, -2, and plug it in, I'll have 2 to the -2 plus 1, which means I have 2 to the negative first power. Remembering back to 7-1, the negative does not determine if it's a negative value. The negative tells me to do the reciprocal. So I do 2 to the first power, which is 2, but then the reciprocal of that would be 1/2. Remembering that negative exponents make it a fraction, or flip it around. Second exponent, 2 to the -1 plus 1 would be 2 to the 0. Anything to the 0 power is just going to be 1. Plug in 0 for x, so 2 to the 0 plus 1 is 2 to the first power. 2 to the first power is 2. Plug in a 1. 2 to the 1 plus 1 is 2 squared. 2 squared is 2 times 2, which is 4. Plug in the 2 for x. 2 to the 2 plus 1 is 2 to the third power, which is 2 times 2 times 2, and I get 8. So now I can plot these points. So at -2, it's 1/2. At -1, it's 1. At 0, it's 2. At 1, it's 4. And at 2, it's 8. So because the original shape in 7.2 of the graph is always going to look like that for an exponential growth, I know I can follow this x-axis as my asymptote. It's the line it will never cross, and then it starts to bend up, 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 up. So my asymptote, or the line that it will never touch, will always be 0, or the x-axis, until I have up and down movement, until I have a shift to it that moves it up or down. So I know the type of graph this is a growth, because I can see in my graph it's growing as I look left to right. Also because of the 2 right here. 2 is a number that is greater than 1, and going back to 7.1, when your base is greater than 1, it is a growth function. My domain is always going to be -infinity to +infinity, and my range, my graph is never going to go any lower than the x-axis, because it did not shift up or down. So in this case, my range is going to go from 0 to infinity. None of my y values will be below 0. Example 2b. Determine if the function is an exponential growth or decay. Graph the function, then we're going to list the domain and range again. This time, looking at the 1/3. 1/3 is a number between 0 and 1, so I know this is going to be a decay. I know I don't have left and right movement, but I do have a movement 2 units down. So this time, because of the 1/3, I'm going to plug it into my calculator to get the values. So I go to y equals, and I'm going to put in parentheses just like it shows, 1 divided by 3, the caret to raise the exponent of x, and then I make sure that I press over so that I can do -2. The 2 is not subtracted from the x. The 2 is our k movement, our movement up or down. And then I hit graph, and I can see that this is an exponential decay. My graph is going to go like this, going down from left to right. And I'm going to fill in my table now by going second graph to pull up the table. I go to -2, and -2 has a value of 7 for the y. -1 has a value of 1. 0 has a value of -1. 1 has a value of -1.667. And 2 has a value of -1.889. So whenever I graph the points, -2, 7, -1, 1, 0, -1, 1, -1.67, so it's about -1 2/3, 2, -1.89, almost to -2. And that pattern of dots is following my exponential decay. So when I put this in, I know I'm going to follow along. And then because my graph was shifted down 2, that means my asymptote, or the imaginary line that the graph will never cross, is now at -2. When you're graphing these, whatever your shift is becomes the line that you eventually never cross, but you just follow really closely. So when I do my domain will never change. It's -infinity to +infinity. This is going to go left and right as far as it possibly can. But my range now changes to my k value because my graph was shifted down, so -2. -2 is the lowest that it can go. It will never touch it, never cross it, and then it will go up to infinity. Example 3. We're going to graph two equations on the same grid and label the lines so we can investigate them in later examples. For both of these, I'm going to use the calculator to plug f of x and g of x into my calculator so I can graph it and get a table. So I put both equations into my calculator. F of x equals 2 to the x power, doing 2, then the caret with the x, and then g of x, 4 to the x power, and then pressing over so that I can now make -3 a k value. -3 is not attached to the x. It is my k value telling me my graph shifts down 3 units. Which is also going to help me to get my asymptote for that one and my range. So to fill in the table, second graph, so I bring up the table for f of x, -2 is at 0.25 or 1/4. -1 is at 0.5 or 1/2. 0 is at 1. Remember, anything to a 0 power gives you 1. At 1 it's 2, and at 2 it's 4. So I'm going to graph that equation. So -2 is 0.25. -1 is 0.5. 0 is 1, 1 is 2, and 2 is 4. So this follows the pattern of it being a growth, which it is because the base 2 is greater than 1. An asymptote of 0, meaning it's never going to touch 0, just follow along it. And then it goes up and increases. Then I go to my table again. Now I can put in the values for g of x equals 4 to the x minus 3. At negative 2, it's negative 2.938. At negative 1, negative 2.75. At 0, it's negative 2. At 1, it's 1. And at 2, it's 13. So I can graph these. Negative 2, I'm at just about 3, which makes sense because I have that asymptote of negative 3 because my graph has been shifted down 3. Negative 1. Let me redo that. Negative 2, that almost 3. Negative 3. Negative 1, 2.75. 0 is negative 2. 1 is 1. And 2 is going to be 13. So somewhere up there. So I have my asymptote. The graph is never going to cross that. It's never going to touch it. It's just going to follow along it closely and then start to grow up. So there are the two graphs. Using my calculator for the table, but graphing it by hand and knowing where each asymptote is. F of x didn't have any up or down movement, so 0. The x-axis was its asymptote. The red line never crosses the blue line. And then see now the green one, g of x, was shifted down 3 units. It had an asymptote at negative 3, meaning it's never going to cross negative 3. It's never going to touch negative 3. So now we need to investigate this on the next slide. So example 3, we have the two graphs shown. F of x is blue, g of x is red. The question says approximate the intervals where f of x is greater than g of x. What that means is, where are the y values increasing faster for f of x versus the y values of g of x. So when I look at f of x is the blue line. G of x is the red line. They both are coming from negative infinity. As we look left to right, they eventually cross each other at what looks like to be 1, 2. So I need to find an interval where f of x is greater than g of x. Well, it looks like all the way from negative infinity, f of x is always going to be higher, because f of x has a higher y value than g of x. So my interval starts at negative infinity, where f of x has greater y values. Once we get to that intersection point 1, 2, all of a sudden, the red line, g of x, jumps up a lot quicker, which means it starts to increase a lot faster than f of x, the blue one. So our interval where f of x is greater than g of x is from negative infinity up until you hit that intersection line at 1. We always look for the x values for our interval. So f of x, the blue function, is greater than the red function g of x from negative infinity until you hit 1. And then g of x, the red one, becomes the function that is increasing more rapidly. So its y values are going to be greater than f of x's y value. Part B, approximate the intercepts, domain, and range. So for f of x, our blue function, there is no x-intercept. The reason being, f of x has an asymptote of 0, the x-axis, so it's never going to cross 0. It's never going to cross the x-axis. But it does have a y-intercept. And the way I can find that is by going to my table that I used and looking when the x value is 0. And for f of x equals 2x, when the x value is 0, the y value is 1, so I have a y-intercept of 0, 1. Or when I plug 0 in for x, 2 to the 0 power will always be 1. My domain will never change. Every exponential function has a domain of negative infinity to positive infinity. And my range, see now it doesn't shift up or down. And I have an asymptote of 0 or the x-axis. My range goes from 0 to positive infinity because it is a growth. Now g of x, the red function, has an x-intercept because it falls below the x-axis, and it looks like its x-intercept is at about 1 where it crosses the x-axis. So my x-intercept is 1, 0. My y-intercept is where it crosses the y-axis, and I can find that on my table from the calculator. Once again, going down to an x value of 0 and looking at the y value that goes with that, which is negative 2. So 0, negative 2 is my y-intercept. Domain, negative infinity to positive infinity. And my range, see now the graph is shifted down 3, negative 3 to infinity. So our final example, it's still the same two functions, f of x equals 2 to the x and g of x equals 4 to the x minus 3. We have them graphed on the same grid. Now we just need to describe the transformation. I've already been talking about it, what the difference is between f of x and g of x. G of x is 3 units lower than f of x, so how we would describe this transformation is g of x is 3 units lower than f of x.